Hi, welcome back to my channel. My name is Gina. In this video, we are going to look at 3 derivative rules that is the most frequently confused trio. That is derivative of a base with an exponent. Say derivative of f of x to the power of g of x. There are 3 different possibilities. When the exponent is a constant n, then we get derivative of a function of x, let's call it u, to the power of n. Then which rule do you use? We use the power rule. So what is derivative of u to the power of n? That is n times u to the power of n minus 1. And since u is a function of x, so we need to use chain rule. So times u prime. Let's look at a quick example. Derivative of x squared minus 1 to the power of 3. Derivative of this, we use the chain rule version of power rule. It is 3 times the inner function x squared minus 1 to the power of 2 times derivative of x squared minus 1, that is 2x. Now let's look at the second case. If the base f of x is a constant b, that is we have derivative of b to the power of a function of x, let's call it u. Then in this case, we use the derivative of exponential functions. Which is b to the power of u, the same, times ln of b. And since u is a function of x, so we need to times derivative of u. Let's look at a quick example. We want to find derivative of e to the power of 2x. This derivative is e to the power of 2x times ln of e times u prime. The u here is 2x, its derivative is 2. And ln of e equals to 1. So this derivative is 2 times e to the power of 2x. In the third case, this is more complicated. That is when both the base and exponent are functions of x. So there is no constant here. And when we have this, we need to use the log differentiation. That is, we want to find the derivative of a function of x to the power of another function of x. I have another video on how to use log differentiation. If you haven't watched that video, I'll put the link up there. A quick summary. Here is the 3-step approach. First step, you take ln on both sides. So you get ln of y equals to ln of the right hand side. Ln of f of x to the power of g of x. The second step is you use the property of log to bring the exponent g of x in front of ln. So you'll get ln of y equals to g of x times ln of f of x. And the third step is to use implicit differentiation. So you take the derivative on both sides. And remember, when you have derivative of y, since y is a function of x, so you need to use the chain rule and multiply by y prime. I also have another video on implicit differentiation. So if you want to review that, I also put the link up there. Let's look at some examples. The first one, we have 3 times ln of x plus 6 times x squared to the power of 2 times e to the power of 5 plus ln of 2. First of all, we need to recognize which one is the constant. Is the base constant? Is the exponent constant? Or they are both function of x? Before you do any approach, we need to identify that in this problem, the exponent is a constant. It may look really complicated, but e to the power of 5 is a constant because e is a constant. And ln of 2 is also a constant. So the exponent, even though it looks really complicated, but it's a constant. So we use the power rule, y prime. Power rule is we bring the power down, so 2 times e to the power of 5 plus ln of 2 times the base, which is 3 times ln of x plus 6 times x squared to the power of the original power minus 1. So that would be 2 times e to the power of 5 plus ln of 2 minus 1. And since the base here is a function of x, so we need to use the chain rule. So we need to multiply by derivative of 3 times ln of x plus 6x squared. Let's bring the derivative of inner function to the front. It equals to 3 over x plus 12 times x. And the rest is the same. 2 times e to the power of 5 plus ln of 2 times 3 times ln of x plus 6x squared to the power of 2 times e to the power of 5 plus ln of 2 minus 1. Let's look at the second example. Similarly, we need to identify whether the base or the exponent is constant, or whether both exponent and base are function of x. Here the function is 2 times e to the power of 3 plus ln of 16 and whole thing to the power of e to the power of x plus 2 times ln of x. We identify that in this problem, the base is the constant because e is a constant, so e cubed is also a constant. Ln of 16 is also a constant. So y prime, here we need to use derivative of exponential function, which remains the same, 2 times e cubed plus ln of 16 to the power of e to the power of x plus 2 times ln of x, then times ln of base, that is ln of 2 times e cubed plus ln of 16. And since the exponent is a function of x, so we need to use the chain rule. Derivative of exponent is e to the power of x plus 2 over x. Let's look at one last example. Here the function is 3 times e to the power of x plus 2 times ln of x to the power of x cubed times e to the power of x. Here we need to identify whether the base or the exponent is constant, or both are a function of x. In the exponent is a function of x. We have e to the power of x and ln of x. Exponent is also a function of x. So here we need to use the log differentiation. First step is to take ln on both sides. Ln of y equals to ln of right hand side. Ln of 3 times e to the power of x plus 2 times ln of x. Then to the power of x cubed times e to the power of x. Then we use the property of log to bring the exponent in front of ln. So ln of y also equals to x cubed times e to the power of x times ln of 3 times e to the power of x plus 2 times ln of x. Then we use implicit differentiation. So we take the derivative on both sides. Derivative of ln of y is 1 over y, and since y is a function of x, so remember to multiply by y prime. And this equals to derivative of the right-hand side. Here we have a function of x times another function of x. So we use the product rule. Derivative of the first function. Inside the first function is also a function of x times a function of x. So we use the product rule here. That is 3x squared times e to the power of x plus x cubed times e to the power of x. Then times the second function, ln of 3 times e to the power of x plus 2 times ln of x. Then plus the first function, x cubed times e to the power of x, and times derivative of the second function. That is 1 over the function inside ln, 3 times e to the power of x plus 2 times ln of x. And since it's a function of x, so we need to use chain rule. So multiply by the derivative of the inner function. 3 times e to the power of x plus 2 over x. So y prime would be y times the right-hand side. Let's call this whole thing the right-hand side. So y prime would be the original function, 3 times e to the power of x plus 2 times ln of x to the power of x cubed times e to the power of x. Then times the right-hand side. And that is the end of the video. If you like my videos, please like and subscribe, and I'll see you in the next video.